Okay, Nicole, so actually on this number 8 one that you sent me, it's not too bad at all, because when I look up here and I consider my normal things, does anything not like negatives, and can I divide by 0? In this case, I really can't, because I have x squared plus 1. The smallest that x squared can be is 0, when I have x equaling 0. Any other amount of x, both positive or negative, is just going to add to that 1, since I'm squaring it. So in other words, when x is 0, I'm going to get a maximum on my function of 4, because that's what's in the numerator. So I would have 4 over 0 plus 1, and that would give me 4 over 1, which is just 4. Now everything else, though, as you look, as we start to get both positive and negative and large, it's going to start trying to get to 0, because that x squared is really pushing that denominator to be very big, which means we're dividing 4 by a very, very big number. So when I'm dividing 4 by a big number, I'm really trying to get to 0, but I'm never going to make it there. So on this one, you've really got kind of a pretty easy one to do, actually. So we're going to have a max up here at 4 if you wanted to talk about something like that. And then after that, I mean, if you plug in 1, you can just see it. 1, I'm going to be down at 2, so I'd be halfway down. Same thing in negative 1. Okay, and if you plug in 2 again, you're going to be now at 4/5, so now you're even smaller than 1. And obviously, if we keep going, let's see, if we did something that was like, trying to get one that's a little easier to see just the result of, but, oh well, I guess, well, it doesn't matter. Put in 100, and 4 100ths is 1/25. So you can see that you're kind of way out here, and we're going to get this nice bell-shaped graph that's coming through the middle here. And again, it's never touching that 0, so I'm trying not to make it happen. That the line of y equals 0 will be a horizontal asymptote. Okay. So hopefully that kind of did that for you. You've got no vertical asymptotes, y equals 0, horizontal asymptote. 4 is your y-intercept, and that's about it. All right, hope that helped. Okay, so for this one, you were asked to sketch a graph, right? So right away, there's a couple things that you think of when you're going to sketch a graph. Because you haven't been really familiar with polynomial functions, you're not into calculus and taking some derivatives and doing extra stuff yet, the best you can do is kind of use the idea of A, where's my y-intercept? So when x equals 0, what do I get out here? In this case, we can see I'm going to get out 0. So I have a y-intercept. I'm passing through the origin, in other words. I have 0, 0 coming out of this function. The second thing you want to do is to start factoring to see where the zeros are. So if we start pulling that out here, and I pull out an x, I'm going to get x times 2x squared minus x minus 1. And now hopefully you're starting to look at this middle one and you're thinking, I can probably factor that a little more. What multiplies to negative 2, right, and then adds to negative 1? Well, we've got negative 2 and positive 1 that can do that. So again, if I factor this down one more level, I have x, 2x, x, and again I want my 2 to be negative and 1 to be positive. So that's going to give me the negative 2x, and it'll give me the positive x, so we're adding in the middle. And now I can see where my roots are. I'm going to have roots at x equals 0, like we said to begin with. I'm also going to have roots at negative 1/2, and then positive 1. And therefore now I have 3 different points that I can put on my graph to try and work with. And then you can start thinking about end behavior. What happens as x gets really, really big? Well, this x cubed is taking over the function. So this being an odd function, one side's going to get tall, the other side's going to get short. Since this is the normal one, it's going to look just like our parent function per se, in the way that it has its end behavior going up as we get positive, and it's getting negative as we go negative. So again, the limit as x approaches infinity is infinity, and the limit as x approaches negative infinity is negative infinity. So now we kind of have everything that we need. We could come through now and just say, okay, at 1, at 0, and at negative 1/2, we know that's happening. And then I know after this I'm going down to 0, down to negative infinity. Over here I'm going up to positive infinity. And then in between I have to make this bend and go through that root, so that means it could possibly look like that. And again, do not think that you have to know how that wiggle looks. It could be that it actually comes up like this and down like that and then back up. You just don't know at this moment. That's why it's called sketch the graph. So as long as you pull out those intercepts and then look at the end behavior, you'll have a good sketch of your graph. Okay, Nicole, so for the last one here, I found another example of kind of what you were working on that form. And it's write the polynomial equation given the following graph and answer in factored form. That's pretty much because that's the only way that you need to answer. If you were to do anything else, you'd be doing more arithmetic. So all we need to really do on here is first focus in on where are our roots, okay? If we know where our roots are, then we can start to split out our factors of our roots. So since I have a root here at -2, I know if I start to write f of x, it's going to be equal to, I'm going to leave a little room here in case I need a coefficient, okay, is x plus 2, because again, when x is -2, I get 0, so that's got to be a root. I also have x equaling 2 being 0, so that means positive 2 is a root, so x minus 2 is a factor. And then out here at 5, where x equals 5, I'm actually bouncing off and going back. That's almost the same thing as passing through twice. You can almost think of how many directions did you go through it. Whenever you bounce off the x-axis, that means you have a multiplicity of 2. In other words, this is going to be a factor of x minus 5 squared on the end, okay? Now we get this one other point down here at 0, -4. And that tells me when I plug in 0 for x, and this value's up here, I should get out -4. Well, at the moment, if I plug in 0 for x, I'm going to get 0 plus 2, which is 2, 0 minus 2, which is -2, and then 0 minus 5 is -5 squared is positive 25. So at the moment, when I plug that in, I'm going to get out 25 times -2 times 2, or 25 times -4. So I get out -100 when I plug in 0 for x. But I know that when I plug in 0, I should be getting out this -4 number. And right now I'm at -100. So now I can figure out what coefficient I need to put in front of my polynomial. And it's whatever I need to get to this -4. So -100 divided by 25 is -4. So that means that I must have a coefficient in front of this of 1/25. So the only thing that I'm missing here now is my 1/25, x plus 2, x minus 2, x minus 5 squared. And I like that because, again, I know that both ends are going up here, so it should have an even function. There should be an x squared, an x to the 4th, x to the 6th, since they're both going in the same direction. The end behavior agrees. If it was the other way around, it would be one of the odd functions, x cubed, x to the 5th, x to the 7th. So when they're both heading up in the same direction, you know that you want to pick off 4 roots, and in this case, the root of 5 just happened to happen twice, and that's why it's called the multiplicity of 2. And then finally, that last bit of finding the coefficient is just doing whatever you have to do to make you know that when you plug in x equals 0, y equals -4 should come out. So you do whatever you have to do to make that happen. And this should be f of 0. Sorry if it looks like f of phi there for a second. But anyways, hopefully that helped out as well.